So I discussed before this electrotonic potential. Electrotonic potential is a very short, it acts over, it transmits a signal or electrical signal over a short distance, but it transmits it fast. And just think of like dropping, imagine you took like a glass of water and you dropped some dye in it. That dye would very quickly drop to the bottom, right, and spread out, and then after a few minutes you may have a glass of like light blue water if you drop blue dye in it. You're with me there? That's similar to how electrotonic potential works. Action potential is very complicated and very specialized, so I'll tell you what it does first, and then we're going to get into the steps of how it works, and then we're going to see how the two work together to transmit a signal in the central nervous system and in most parts of the peripheral nervous system. And this stuff is fun, but we break it down step by step. Action potential is much slower than electrotonic potential. It's much slower. Action potential requires quite a bit of energy. It's quite energy consuming. Action potential helps move a signal forward. Action potential helps move a signal forward. You know, you could think of it like this. Action potential helps keep the signal going in one direction. And you might say, yeah, but it's slow, so why do we use it? Why is it necessary if it's slower than electrotonic potential? Well, you need both. Action potential helps move a signal forward. Electrotonic potential helps move a signal fast. Forward and fast, forward and fast, forward and fast. This is called saltatory conduction. Saltatory conduction. So actually it comes from the Latin word saltus, which means to jump. How do you say jump in Spanish, someone? Saltar. Saltar. So it's saltar. It's related to that, to jump. But we will see that this is not jumping. It appears to be jumping, but it's not jumping. That's what confused me for so many years. I'm like, how is this jumping? Why do you call it jumping? Because the people that first saw how the signal was being transmitted, they saw this signal jumping from one part of the axon to another, and they thought it was like boom, boom, boom. They thought it was like a jumping signal. It's not a jumping signal. It's a combination of electrotonic potential and action potential together. The two kind of have to work together in order for a signal to be effectively transmitted in our central and in most parts of our peripheral nervous system. Saltatory conduction. It'll be on the next slide. Saltatory conduction. And I always say this in class, it's called saltatory conduction because it's referred to as jumping, but there's no jumping involved. If you think saltatory conduction, where is the jumping happening? And a lot of textbooks have these like arrows that go up and down and you think something's jumping. It's not jumping. Jumping's dangerous, kids. Don't do it. Okay? No jumping. Public service announcement. Don't jump at home. Okay? So this is what I always teach the students every semester. Saltatory conduction is called jumping, but don't jump because jumping's dangerous. Right? Why don't we jump? It's dangerous, right? So don't get into that logical... That's what screwed me up for so many years learning this stuff. It's like jumping, conduction. What the hell is... There's no jumping going on? But there's no jumping. It appears as if a signal is jumping, but it's not because jumping's dangerous.